Hello everyone. So welcome to my second class. Let's crack UPSC, right? And I say let's crack CSAT. So we know that Unacademy is India's largest learning platform, guys. And we got India's best educators. You know the names, you know the pictures. Guys, please go for Unacademy subscription. Use the code for plus as well as for Iconic. You can use the code YTUPSE. Also, you can go for the combo subscription for the same and you can use the same code YTUPSE, right? Unacademy optional subscription, guys, there is a 10% discount with the same code YTUPSE, so you can go for that. Also, please, November extension offer, crack UPSC CSE with extended benefits. With 9 months, we are giving 2 months free. For 12 months, we are giving 3 months free, and so on. You can read them. And guys, it is only valid till November 15th. So you use the code RUPSC, all capitals, right? And join the subscription. Also, guys, we are launching the ultimate batch for UPSC CSE 2023 bilingual. You can subscribe, and it has already started November of 10th. And you also know the results, guys, right? We are the leaders when it is concerned about results. And guys, yes, don't let CSAT block your selection. Don't let CSAT waste your year, right? So please prepare well. We have got the best educators. You can actually join the CSAT course. We cover all the topics like RCs, aptitude, reasoning, data interpretation. There would be 20 practice tests. So the subscription, again, you can use the code RUPSC. RUPSE, right? That's a code, and you can actually join an individual CSAT course, right? Also, guys, the IAS officer is revealed November 13th, 11 a.m. Mr. Gaurav Budania, right? So now, guys, you can actually avail EMI options also. So if there is a problem, this problem can easily be sorted out. So 0% EMIs, you need to call at 8585858585. So today we are going to talk about divisibility rules are to be continued, because we have done divisibility rules till 7. So we will continue. My name is Rishi Bhargava, and I expertise in teaching students CSAT, and I would keep it very simple, and it will cover each and every topic. All right. So I hope you enjoy the experience with me. My Telegram link, you can join my channel Rishi Sir UPSC, and my community is Bhargava Rish. So let's crack UPSC has let's crack CSAT, right? And we were talking about divisibility rules, right? And we have done these rules till 7, divisibility rule of 7, right? And now we need to continue further, right? So divisibility rule of 8, rule of 8. Now pairs of 2 have distinct rules. Pairs of 2 have distinct rules. So divisibility rule of 8 says last 3 digits are exactly divisible by 8, or the number ends with 3 zeros, or the number ends with 3 zeros. So any number which is ending with 3 zeros, it is exactly divisible by 8. You may ask, why, sir? So I say, what about 69000? This is exactly divisible by 8. Why? Because it can be written as 69 into 10 into 10 into 10, which would give you 69 into 2 into 5 into 2 into 5 into 2 into 5. So there are 3 2's, and there are 3 2's, so that would make 8. So the number is exactly divisible by 8. So any number which is ending with 3 zeros is exactly divisible by 8. Now, as far as rules are concerned, we know what is divisibility rule of 4. So 4 is 2 to the power 2. Then we say last 2 digits, right? 8 is basically 2 to the power 3. Now the rule becomes last 3 digits. So basically the power of 2 gives you the rule. So if I say what is divisibility rule of 16, 16 is what? 2 to the power 4, then you would say last 4 digits are exactly divisible by 16 or the number ends with 4 zeros. So now I hope this is clear. Divisibility rule of 32, 32 is 2 to the power 5. So we would say the last 5 digits are exactly divisible by 32 or the number ends with 5 zeros, right? So keep this thing in mind. We are not bothered about what is the length and the breadth of the number. We just look at the last 3 digits for 8. For example, I say 7989163840. Is this number divisible by 8? So you don't need to check the whole number, just check the last 3 digits. The last 3 digits are 840. 840 is exactly divisible by 8. So the whole number is divisible by 8. And it applies to remainders as well. Meaningly, if you are given a number and you need to find a remainder dividing by 8, then you just divide the last 3 digits by 8 and get the remainder, right? So please write it properly, guys. This is important. This is something I'm not going to discuss the divisibility rule now. All right. Clear? So then following on to it is divisibility rule of 9. 9 is a important digit. 9 is a very important digit. Many a times I've seen a question in UPSC CSAT and it contains divisibility rule of 9. So I'm going to discuss it properly. The rule says sum of the digits is a multiple of 9, right? So you add on the digits and the sum comes out to be a multiple of 9. The number is exactly divisible by 9. Now for example, right, I can write one number. So is this number divisible by 9? Now you know 1 plus 8 is 9. So see, this sum is 9 plus 9 plus 9 plus 9 plus 9 plus 9. So 6 times 9, isn't it? So it's actually 1, 2, 3, 4, 5, 6. 6 times 9 is 54, right? The sum of this comes out to be 54. And 54 is exactly divisible by 9. But my advice to you is don't make a 2-digit number. Make a single-digit number, which is 9. So the rule is, first thing, keep this thing in mind, that if the sum of the digits comes out to be 9, the number is exactly divisible by 9, right? Simple as it is. Single digit number should come out to be 9. That's really important. So don't go beyond that, all right? Otherwise, if it doesn't come out to be 9, it would leave remainder. For example, I say what is the remainder when 1113 is divided by 9. Now I don't want to divide it. So I say what is the remainder when 1113 is divided by 9. So add all these. So comes out to be 1 plus 1 plus 1 plus 3 comes out to be 6. So the remainder is 6. So it is giving you two-way things. It is giving you checking the divisibility and it is giving you remainder as well, isn't it? So both ways it is going, isn't it? Both ways it is going, isn't it? First thing, it is giving you exactly divisible, or second thing, it is giving you remainder. So when it is not exactly divisible, you will get a remainder. And now remainder also would be a single digit number. Why? Because whenever you divide a number by 9, possible remainders are 0, 1, 2, 3, 4, 5, 6, 7 and 8. So a single digit remainder would also come. So 9 is so easy. So whenever you want to divide by 9, so rather now if we can change, I say ignore multiples of 9. That would actually be better, na? Because as we did in divisibility rule of 3, ignore multiples of 3. So can't we do ignore multiples of 9? Right? So for example over here, For example, over here, 1 plus 8 is 9, ignore 2 plus 7 is 9, ignore 3 plus 6 is 9, ignore 4 plus 5 is 9, ignore 6 plus 3 is 9, ignore 7 plus 2 is 9, ignore. So whole number is ignored, the number is exactly divisible by 9. Right. And for example, you take one more example, 1, 1, 2, 7, 1, 1, 3, 6, 9, 4. What is the remainder when this number is divided by 9? So first of all, cancel off the multiples of 9. 2 plus 7 is 9, cancel. 3 plus 6 is 9, cancel. This is cancelled. Right. And then what is left? 1 plus 1 plus 1 plus 1, 4 plus 4, 8. So remainder 8, sir. I think this is far, far, far better. Do you agree? All of you. Right. So now remember, wherever there is sum of the digits, ignore multiples. So what is divisibility rule of 9? Ignore multiples of 9. Right. So if the whole number is ignored, the number is exactly divisible by 9. If something is left, that is remainder. Sir, one more example, sir. So I say, what is the remainder when 2, 1, 3, 1, 4, 7, 9, 6, 3, 4, 2, 6, 3, 2, 4 is divided by 9. So first of all, find multiples of 9. Anywhere cancel it. 9 gone, right? 7 plus 2, 9 gone, right? And then 3 plus 3 plus 2 plus 1, right? 3 plus 3 plus 3 is 9, gone. And then 1 plus 4 plus 4 gone. So the number is exactly divisible by 9. So whenever I write a number on the board, listen to me, the probability of it being a multiple of 9 is 1 by 9, right? So I have written, just abruptly written, and I have got a number which is exactly divisible by 9. I hope you got it, right? Now why 9 is important? UPSC has hit this many a times. Why 9 is important? So let me just tell you why 9 is so important. It is important because I'm writing few things, right? Point number one, every multiple of 9 is a multiple of 3, but every multiple of 3 is not a multiple of 9. So every multiple of 9 is a multiple of 3, but vice versa not possible. 6 is a multiple of 3, but it is not a multiple of 9. 12 is a multiple of 3, but not a multiple of 9. 15 is a multiple of 3, but not a multiple of 9. 18 is a multiple of 9 and a multiple of 3, right? So keep this thing in mind. Every third multiple of 3 is a multiple of 9. Why? Because 3 is a 9. So every third multiple, I can say every third multiple of 3 is a multiple of 9. First important point, keep this thing in your mind so that we do not mess up with rule of 3 and rule of 9. Rule of 3 says sum of the digits is a multiple of 3. Rule of 9 says sum of the digits is a multiple of 9. So do not mingle it up. Clear? Then second part, which I find to be really important, is this: a number minus its reverse. A number minus its reverse is a multiple of 9. This is always true. This is always true, and UPSC has given this many a times, a number minus its reverse. Right? UPSC has given this. So first of all, why? First of all, just check out, sir, how is this possible? So just check out two-digit number 81 minus 18 is 63, a multiple of 9. I'm not lying, just check out. You may say, sir, are you sure? Just check out. 20 minus 02 is 18, a multiple of 9. I'm not lying, right? 92 minus 21, 29. So 92 minus 30 plus 1 is again 63, a multiple of 9. Sir, check out three-digit number, sir, right? So I check out three-digit number, I say 321 minus 123 is 198, a multiple of 9. Why 198 is a multiple of 9? Here, check out sum of the digits, or maybe ignore 1 plus 8, 9, 9 ignored, number is exactly divisible by 9. Sir, it is always true. Sir, then there are brilliant students, those who say, sir, acha, do this. 252 minus its reverse is 252, which is equal to 0. 0 is a multiple of 9 because 0 is a multiple of every number. 0 can be written as 0 into 9. So now you cannot deny it, right? This is called a palindrome. Palindrome is a number which exactly is number written from the left to right or right to left. It's the same number, right? So palindrome. So again it is a multiple of 9. So rather than saying, sir, shall we remember it, just keep this thing, a very simple thing in your mind. I think this is something we generally tend to miss. AB minus BA. Now AB is a 2-digit number. AB is a 2-digit number, can be written as 10A plus B minus 10B plus A. So comes out to be 9 times A minus B. This is the reason it's a multiple of 9, because 9 is coming. This is the reason it's a multiple of 9, because see, 9 times A minus B. Or maybe you think of a 3-digit number, ABC minus CBA. Now guys, please, I just want to show this. Many of you may not be knowing this. 72 is 7 into 10 plus 2 into 10 ki power 0. It's called base 10, base 10 opening up, right? So that is the reason I've written 10A plus B, right? Similarly, 343 can be written as 3 into 100 plus 4 into 10 plus 3. So this is the opening up of a 3-digit number. So ABC minus CBA will come out to be 100 times A plus 10 times B plus C minus 100 times C plus 10 times B plus A, right? So if you just minus it, this comes out to be 99 times A minus C. Again 99 comes out, it is exactly divisible by 9. 99 is exactly divisible by 9. So now you are sure that a number minus its reverse is a multiple of 9 also. But 99 is actually 9 into 11 into A minus C. So do you think a number minus its reverse, so this is a question for all of you, a number minus its reverse, is it a multiple of 11 as well? That's a question, right? Definitely not in a 2-digit number. In a 2-digit number, a number minus its reverse is a multiple of 9 only. But in a 3-digit number, a number minus its reverse is a multiple of 9 as well as 11. So do you think it's right? So only when it is, when is it right, right? Let's talk about when is it right. So there is a lot of curiosity that you might be having, and I don't want you to, carry on that curiosity. When is it right? A number minus its reverse is a multiple of 9 always. But a number minus its reverse is a multiple of 11 when it's a 3-digit number or a 5-digit number or a 7-digit number or a 9-digit number or a 11-digit number. Which means when the number of digits in that number are odd. 3 digits, 5 digits, 7 digits, 9 digits. So please write it somewhere, right? Giving you time to write it. Come on guys, just write it properly. So I hope now I am clear why 9 is so important, because this has come in UPSC many a times. So I remember a question where he says he has this xyz plus yz x plus z xy, and he was asking about multiple options whether the number is, and he said that x and y and z, x plus y plus z, are not multiples of 9. So he was asking about whether this number is divisible by 3 or 27. This was the option, I don't remember, but I can open it up. So this comes out to be, guys, 100 times x plus 10 times y plus z plus 100 times y plus 10 times z plus x plus 100 times z plus 10 times x plus y. So if you say this plus this plus this, it is 111 times x plus y plus z. And 111 itself is a very special number. It comes out to be 3 into 37 into x plus y plus z. So now you realize this is UPSC question, so UPSC CSAT question. So they are mixing algebra with number system. And that is the reason number system is really, really important, right? See, They have mixed it. So if you have no idea of how to open a number, a 3-digit number has to be written as, 100 times x plus 10 times y plus z, and many of you say it's a very simple paper. Tell me, if you don't know how to write it, how would you sort out this question? Not possible, right? So kindly write it. I think it is 2019 or 2020, I think 2020 the question was here. So you can join the plus classes, guys, where I am going to do each and every UPSC question as well, launching the plus course very soon. All right, so I hope now this is clear to all of you, how to open up, right? And 9 happens to be important. Always keep this thing in mind. Why? Because some of the digits matter. So many a times I say, so what is the remainder when 1 is divided by 9? And many a times people are making this mistake. No, the remainder is 1 plus 1 plus 1. How many ones are there? 7 ones. So remainder is 7. That's it. Sum of the digits matter, right? Sum of the digits matter. So divisibility rule of 9 is done. Now let's talk about the toughest rule. Divisibility rule of 10. Rule of 10. Is it tough? No, it is not. Sorry, just joking. Divisibility rule of 10 is easy. A number is exactly divisible by 10 if the number ends with a 0. I think this is particularly easy, isn't it? So I don't think it is tough. This might be the easiest rule available. But I really like one thing about 10. I'm writing it. Whenever you divide a number by 10, its unit digit is the remainder. Whenever you divide a number by 10, its unit digit is the remainder. So rather than writing, I can give you an example. So suppose I say 43. So when you divide by 10, remainder is 3, right? 441, when you divide by 10, remainder is 1. 3, 4, 3, 1, 1, 9, 7. What is the remainder when divided by 10? Remainder is 7. Unit digit is the remainder. Now you have to keep this thing in mind, because I'm going to come back to this again. I have to do unit digit of a number. During that time, I'm going to come back to this. So at that time, I hope I'm going to remind you again that this is what we have done. Clear? So I hope now we are cool with it, right? So divisibility rule of 10 is gone. Divisibility rule of 11. Oh guys, rule of 11, huh? All of you know something. Sir, this is easy as it is, huh? Sum of odd places minus sum of even places is a multiple of 11. I have heard this. Sum of even places minus sum of odd places is actually equal to 0 or a multiple of 11. Then the number is exactly divisible by 11. Most of you know it. If you don't know it, let's do it today, right? I say 583, 583. Is this number divisible by 7? So sum of even places, see, second place, fourth place, sixth place. Sum of even places is 8 plus 5 plus 3, which is 16. And sum of odd places, 5 plus 3 plus 8 is again 16. So I say sum of even minus sum of odd comes out to be 16 minus 16, which is 0, which means 583 is exactly divisible by 11. This was a rule that we knew during the school time. But now I don't take this as a rule. I ask you why. Very simple question is, why would you take my logic? Why would you take it? Because it was written over there, so you have taken it, or there is some reason behind it? I think with divisibility rule of 7, I have created a beautiful reasoning. I hope you may be thinking how the divisibility rule of 7 was 1 minus 2 minus 3 minus 1 2 3. Many of you can come to the plus courses and discuss these things with me if you feel like discussing. I am a pure mathematician, MSc Maths, MPhil Maths, MBA in Marketing. So I would love to discuss if you want to discuss it. But I can also give you a chain behind 11 and give the reason for this rule. You should have asked it during the school times, 8th class, 7th class, but you did not. So I'm giving you the reason today. There is a series behind divisibility rule of 11. It is 1 minus 1, 1 minus 1, 1 minus 1 and so on. So that is the reason. Actually it is sum of even minus sum of odd places. So suppose I have to check is 583 divisible by 11. So 583, you write it below this series and then you multiply. 5 ones are 5 and this is minus of 8 and this is plus of 3, this is minus of 5, this is plus of 8 minus of 3, and if you add up comes out to be 0, which means this number is exactly divisible by 11. So with this series, if you get a multiple of 11, or a 0, the number is exactly divisible by 11. Keep this very simple fundamental in your mind, and the beauty of this series is it goes till infinity like this: 1 minus 1, 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 1 minus 1. You can take it to infinity. So if I ask you, so I can abruptly give you a number, na? So I say 1 0 0 0 0 0 0 0 0 0, oh, sorry, 0, and this is 1. Is this number divisible by 11? So without any doubt, 1 ones are 1 and 1 into minus 1 is minus 1, which means we get 0 as an answer, which means this number is exactly divisible by 11. So now we are sorted out with 11 as well. I hope you like it. I hope you love it. This is something really good, isn't it, guys? Then divisibility rule of 12. Rule of 12. Again, listen, whenever you want to break up a number. Now 12 is a composite number, and 12 you have to break it into even number, two prime numbers. If not prime, one of them has to be prime. So many a times, 12, why not 2 into 6? So why can't we write rule of 2 and rule of 6? I say it is wrong. Why? Because 2 and 6 have same parity, meaningly both are even, right? So try to get opposite parity, which means rule of 12 would better be 3 and 4, right? Why? Because one number is 3 is prime and both the numbers are of opposite parity. 3 and 4, one is even, one is odd. So then it's a better way of breaking a composite number to get a rule. So not 2 and 6. Many a times a lot of students would ask me, sir, why not 2 and 6? I would say this is the reason, right? So rule of 3 and rule of 4, which means an exact multiple of 12. Now please pay attention. Exact multiple of 12. Sum of the digits is a multiple of 3 and last two digits are multiple of 4. A number is exact divisible of 12 and the sum of the digits is a multiple of 3 and the last two digits are exactly divisible by 4. Right. So if I want to find a 4-digit number exactly divisible by 3, so first of all write the last two digit 24. So I know any number ending with 24 and I am leaving remaining two spaces open. Now I know any number ending with 24 is going to be divisible by 4 and 2 plus 4 is 6. So I can write 1, 2, 2, 4. This is exactly divisible by 12, isn't it? So you may think of, sir, 76. Now 76, any number ending with 76 is absolutely divisible by 4 because last two digits are 76. Now you need to fill the remaining spaces. What is 7 plus 6 is 13. So you have to make a multiple of 3. So 13 plus 3. So you can say 2176 is a multiple of 12. Isn't it? 13 plus 3, 13 plus 2 करना चाहिए. So 1176, right? 1176. 13 plus 2 is what? 15. So 1176 is a multiple. Again, you can choose like 76 is 13. So what should be added to 13? So 13. What should be added to 13 so that we make a multiple of 9? So 13 plus 8 is 21. So you want to put 8. 4476. So now this is a multiple of 3 also. This is a multiple of 4 also. It is a multiple of 12. So this is the way it is. And they can give you a question in series. Like we have done a question of divisibility of 6. So I think check out this question. I say I have a number n which is 1419 into 1421 into 1423. Find remainder when n is divided by 12. And a very same kind of question was there in UPSC CSAT year 2022. So you can check out that question as well. Not divisibility by 12, it was not divisible by 12, it's a bigger number. We are going to talk about remainders in the next class. So you would also get to know it, right? So what is the remainder when this number is divided by 12? Now, I'm not going to multiply the whole number and divide by 12. It will take me 2 hours, 1 hour, something like that, right? So I don't want to test my calculation skills over here. So rather I would say, what is the multiple of 12 less than 14, 19? So I check out a multiple of 4. So any number ending with 16 is a multiple of 4. 14, 16 is a multiple of 4. Check out, is 14, 16, 1 plus 4 plus 1 plus 6. Is it a multiple of 3 as well? Yes, it's a multiple of 3 as well. So 14, 16 is a multiple of 12. Now just check out the difference between 14, 19 and 14, 16, remainder 3. Then luckily, what is the difference between 14, 21 and 14, 16, remainder 5, and 14, 23 and 14, 16, remainder 7. So we found personal remainders. Well, we have to find personal remainders. So every number when divided by 12, the remainders are 3 and 5 and 7, isn't it? Now please pay attention. I don't want to multiply 3 and 5 and 7. What is 3 5s are 15. 3 5s are 15. 15 when divided by 12, remainder is 3. So I'm not interested in calculating at all. I know 12 would leave remainder 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So I say 3 5s are 15. 15 when divided by 12, remainder is 3. And then again 3 into 7 is 21. 21 when divided by 12, remainder is 9. So your answer is 9 as remainder. Your answer is 9 as remainder. I hope this is clear to all of you. Clear, guys? So I hope that 6 and 12 is giving you a beautiful method also whenever series of numbers have come and being multiplied. In that case, you are not going to miss out, right? Please write this explanation. This is really, really important explanation. Then comes the most important one, huh? The most important divisibility rule of 13. Again, many a times I've seen many books, I've seen many, people telling that there is no rule for 13. And I feel bad about it. There is no rule for 13? How is it possible? There is a rule for 13, right? And when I said I give a chain, and if you want to discuss about the chain, please, I invite you for the plus classes. I'm launching very soon. You can discuss the chains with me, right? I am not giving it like a freakish thing, right? There is a reason behind the chain, right? So I can talk about like Pythagoras theorem and Pythagorean triplets. And I realized that I found a lot of results for Pythagoras theorem, and I was very happy that I found something new. But I went to a library, I checked out. So these results are actually already found 1500, 2000 years back, right? So these chains have a reason. So chain of 13 is 1, 4, 3, minus 1, minus 4, minus 3. Ooh, right? Just remember it. So if you want to check a multiple of 13, so suppose I say I want to check is 13, 26 a multiple of 13. Everyone knows it is. Just check it, 13, 26. So start from the left hand side, guys. This is most important. Start from the left hand side, right? So 1 1's a 1, and 3 into 4 is 12, and this is plus 6, this is minus of 6. Your answer is 13. So if over there in the answer you get a multiple of 13 or 0, the number is exactly divisible by 13. Yes, don't disclose this rule. Right? I just joking. I hope that everyone knows it. I hope that no one struggles, right? And I hope no one says there is no rule. That's really important to me, right? There are rules. The best part of this rule is it's not a confined 6-digit rule. It can be used as many times. 1, 4, 3, minus 1, minus 4, minus 3, 1, 4, 3, -1, -4, -3, and so on. So it can be used many a times. So you can check out divisibility of numbers, just put it below and get your answers, right? For suppose I say, right, is 777777, is this a multiple of 13? Many of you may deny it. Many of you said, no, no, sir, this is not a multiple of 13. Check out 777777. 7 sevens are 7 ones are 7, and this is 28. This is 21 minus 7 minus 28 minus 21. 0. 777777 is exactly divisible by 13. Huh? You got to know it today. See, that is a beauty. That is a beauty. And now I'm giving you a few results that would be really, really useful. I hope you would appreciate them. First is 7 into 11 into 13 is 1001. Keep this thing in mind. Wherever you see 1001, 7, 11 and 13 comes into play. Keep this thing in mind, right? So please write it 7, 11, 13, 1001, right? 1001, right? Secondly, guys, any number which is written like this, AA, a number written 6 times, meaningly I'm talking about 11, 11, 11, 22, 22, 22, or 33, 33, 33. I hope you're getting it. Till 99, 99, 99. Any number which is written 6 times like this is exactly divisible by 7, 11, 13, and 37. And 3 as well. So you can write 3, 7, 11, 13, and 37. Why 37? Because obviously, if you take, over here, you take, suppose you are checking this. So take 9 common, it is 1, 1, 1, 1, 1, 1. So over here, if you take 1, 1, 1 common, it is 1, 0, 0, 1. That is the reason. That is an absolute reason. All right. So why now triple one is what? 9 into triple one is 3 into 37 into this comes out to be 7 into 11 into 30. So that is the reason any number written 6 times is exactly divisible by 3, 7, 11 and 13. Clear, guys? So good result. And any number of the form ABC is also exactly divisible by 7, 11 and 13. So this is nothing to do with 3 or 37, maybe, may not be, but it would be exactly divisible by 7, 11 and 13. That is true. ABC. So sometimes if you are asked, write a multiple of 13. So you say 583, right? You say 777777. So the other person may be shocked, but yes, it is divisible by 13. For example, this ABC guys, for example, this ABC thing, right? So let's talk about ABC thing. So if you say, sir, how ABC is divisible by 7? So just writing it ABC. So if you write the rule of 7, 1 minus 2 minus 3 minus 1 2 3. So just check out, you would get A minus 2B minus 3C minus A plus 2B plus 3C, which comes out to be 0. So then definitely the number is exactly divisible, isn't it? Definitely the number is exactly divisible by 7. Similarly, you may check for divisibility or rule of 11. So if you want to check for 11, just put 1 minus 1, 1 minus 1, 1 minus 1. It would be A minus B plus C minus A plus B minus C, which is again equal to 0. Right? So again, this number is exactly divisible by 11, right? And then, for divisibility rule of 13. So I am doing it for you. I hope you are understanding it now. So divisibility rule of 13 is 1, 4, 3, minus 1, minus 4, minus 3. So it is A plus 4B plus 3C minus A minus 4B minus 3C, which is again equal to 0. So now though you can easily say that any number of the form ABC is exactly divisible by 7, 11 and 13. I'm not sure about 3. I'm not sure about 37. Maybe, may not be. I don't care, right? But it is divisible by 7, 11 and 13, right? So guys, I hope that remaining divisibility rules 14, 2 and 7, 15, 3 and 5, 16 last, 4 digits, 17 there is no rule. Yes, the chain cannot be formed. We can discuss it. If you are into core mathematics or physics or into research, we can discuss it. There is a chain for 17, but it does not repeat itself. And I haven't seen 17 as number that divides particularly and the remainders are asked. We just do not frame questions just because we want to kill you, right? We frame questions because we want to judge your knowledge. 18 is 2 and 9. 19 we will discuss someday, yes. And that is a beautiful rule actually for 19. We may discuss it someday. Now I hope you would actually be happy and satisfied with divisibility rules. So let me discuss something, guys, really important for all of you. See, out of 57 out of 79 questions from GS mains were from our test series. Wow, that is really important, guys. I hope that you would appreciate the efforts put in by our educators as well as our content team. They are doing brilliantly well. And then the last mile UPSC CSE free interview guidance program. So we invite you all, please. We have top bureaucrats, top educators, professors, so experts. It would be really awesome. And yes, make Unacademy Civil Services Championship your next goal. Sachin says that, right? Come on, guys. 50 MCQs, 60 minutes. And top 50% participants to win guaranteed Unacademy scholarships. That is awesome. November 13th, 11 a.m. Right. And guys, at the end, thank you so much. It's amazing. Let's crack CSAT together. Right. So my greetings to all of you. At the end, I would say Jai Hind.